Hi, 8th grade. This is lesson 1 of module 11, prove the Pythagorean theorem. So that's what we're going to be looking at in the next few lessons is the Pythagorean theorem. The I can statement says, I can prove the Pythagorean theorem, use the Pythagorean theorem to find unknown side lengths of right triangles, and identify a Pythagorean triple, which we'll talk about down here. If you have not done the Spark Your Learning, go back and do that now. It's really interesting, and it'll be a great way to get you into this lesson. So let's look at this build understanding, and then you can pause and work on it, and then we'll come back and go through it together. So the Pythagorean theorem states that in a right triangle, the square of the length of the hypotenuse, the longest side, which is opposite the right angle, is equal to the sum of the squares of the lengths of the legs. So the shorter legs in a right triangle are they're called the legs, and the longest side or longest leg is called the hypotenuse. And so they give you a really good example here. If A and B are the lengths of the legs and C is the length of the hypotenuse, then A squared plus B squared equals C squared. You'll know that for the rest of your life. So it says Pythagoras was a Greek philosopher and mathematician whose name is given to the Pythagorean theorem. You can use what you know about similar triangles to prove the Pythagorean theorem. And hopefully you did the Spark Your Learning, because that was another way to prove it. All right, so let's look at what they say here in A. It says using triangle ABC, which is this triangle here, draw a line from point C. So I kind of did this ahead of time, point C perpendicular to the hypotenuse. And perpendicular, if you remember, means that, so two lines, when they're perpendicular, they'll form a right angle there. So there's the right angle. Label that point D where it intersects the hypotenuse. This breaks this length C, you can see that there, into two smaller parts. Label AD as length E and label DB as length F. So I did that ahead of time just to give you an idea of what they're asking. And then they say label AD as length E. So here, DB as F, they want you to repeat the labels in the two smaller triangles. So here's DB, so that's this, so that's F. AD is E, and so that goes there. So pause here and work on B, C, and D, and E on your own, and then we'll come back and work on those together. So if we look at B, it says because of angle-angle similarity, triangle ABC is similar to CBD. And so you have to make sure that you're thinking of the corresponding angles being in the same place. So what they're saying here is that A is similar to C, and then C is similar to A, and ACD. So here's ACD. And what do you know about the corresponding sides of similar triangles? If you remember, we know that the corresponding sides of similar triangles are proportional. So you could just say they are proportional. C, use similar triangles to compare corresponding hypotenuses and corresponding longer legs in CBD and ABC. So if we look at triangle ABC, oops, I don't mean to have that written like that. Let me get my pointer and said, they're comparing, over here, they're comparing A, which is this bottom leg, or the base leg, I guess you could say, to the hypotenuse. So they're saying A over C. So if we look at this triangle and we compare this bottom or base leg to the hypotenuse, it would be F over A. So A should go here in that box. And then it says use similar triangles to compare corresponding hypotenuses and corresponding shorter legs. So again, in ABC and ACD this time. So they're comparing the hypotenuse C. Oh, let's use this. The hypotenuse C here to B, this shorter leg. And then if we want to look here, if we compare the hypotenuse B to the shorter leg, it would be E. In D, they say use the multiplication property of equality to rewrite the equations. So that means CF would equal A squared So they're saying if A over C here in this one equals F over A, then I can multiply F times C, and that should give me A times A, which is A squared. And then here, C times E, or B equals B times B, or B squared equals CE. Use addition to write A squared plus B squared in terms of CE and F, then simplify to complete the proof. So I wrote it out already so we can just save time, and I'll just explain what we're doing here. So we can look at what we have here. C times F equals A squared. B squared equals C times E from what we did up here. So that means I can take A squared plus B squared, I can add those together, and I can say that because A squared equals CF and B squared equals C times E, I can say A squared plus B squared equals C times F plus C times E. So now I keep my A squared plus B squared, and I can say that that is the same as C times the quantity F plus E. And then what I did is I just took that common factor C, I pulled it out, kind of the reverse of the distributive property, and then I can say that equals C times the quantity F plus E. And you can see if you use the distributive property, C times F plus C times E. So now I can say, because I know that F plus E here is the same as C, I can say that A squared plus B squared equals C times C. I just substitute C for F plus E. Then that leads me to C, A squared plus B squared equals C squared, because C times C equals C squared. And so let's look quickly at this vocabulary. A Pythagorean triple is a set of positive integers, A, B, and C, that fit the rule A squared plus B squared equals C squared. And we'll look at that a little more in lesson 2, but it just means that if you have a triangle where the squares of the two shorter sides added together plus or equals the square of the hypotenuse. So let's look at the step it out quickly. The video is already kind of long, so let's do this kind of quickly. It says use the Pythagorean theorem to find the length of the set of stairs. So pause the video here, work on it on your own, and then come back and we'll look at it together. So A says use the equation A squared plus B squared equals C squared. Substitute the leg lengths into the equation and simplify. They give you the leg lengths here, 5 feet and 12 feet, and they're trying to find what is the length of the squares, and in this case it's the hypotenuse C. So you just have to plug those numbers in. 5 squared plus 12 squared equals C squared. So 25 plus 144 equals C squared. 169 equals C squared. Then take the square root of both sides to solve for C. So the square root of 169 equals the square root of C squared. The square root of C squared is C. 13 equals C. So those stairs are 13 feet long. So that is the end of lesson 1. I will see you in module 11, lesson 2.